Hello student, welcome to all of you in the next physics lecture. This is the video number 33. Myself Rajesh Lagat, physics teacher. Now we have to see here chapter number 5, oscillation. In previous lecture we have to see here the differential equation of linear SHM, that is m into d2x upon dt square plus kx is equal to 0, and also find out the expression for acceleration, that is the minus omega square x. This is very simple one. Now we have to see here the two expression. This is the very important. The expression for velocity and the expression for displacement. First we have to find out the expression for velocity. Then we know that the expression for the acceleration. We remember the expression for the acceleration is nothing but acceleration is equal to minus omega square x, and acceleration in differential form is nothing but d2x upon dt square is equal to minus omega square x. First you have to remember, find out the expression for velocity, you have to remember the expression for acceleration. We have to find out the expression for acceleration, then you have to remember the differential equation of linear SHM. Depends upon step by step. Therefore, we find the expression for velocity, then we know that the acceleration for the particles performing SHM, which is given by d2x upon dt square is equal to minus omega square x. Then we can split up these terms d2x by dt square in such a way that d by dt of dx upon dt RHS term is same as like this, minus omega square x. Then again this dx by dt is nothing but what? Rate of change of displacement with respect to time, and this is nothing but the velocity, so that we can write here dv upon dt is equal to minus omega square x. And then we can rearrange the terms, multiply and divide by this dx. In physics you have to remember, we have to adjusting these various terms in such a way that arrangement the multiply by dx and divide by dx. Therefore dv upon dx and into dx upon dt. Suppose that dx cancel, then dv by dt, this term is remain as, but we have to obtain this integration form so that we can arrange these terms in such a way that dv by dx into dx upon dt is equal to minus omega square x. Then again this dx by dt is nothing but what? This is the velocity, rate of change of displacement with respect to time. This is the velocity v, and dv by dx, this term is as it is, dv by dx as it is, and dx upon dt is nothing but what? Velocity. Therefore v into dv upon dx is equal to minus omega square x. Then this dx denominator term, take this numerator. Therefore v into dv is equal to omega square x into dx. V dv is equal to minus omega square x into dx, and then we can take the integration of above equation on both sides. Then integrating this, integration of v dv is equal to this constant terms minus omega square into integration of x dx. You know that this well formula for the integration x raised to n into dx, integration of these terms is nothing but what? X raised to n plus 1 upon n plus 1. So that this v dv we can write here v square upon 2. You know that this well. V dv is integration v square upon 2 is equal to minus omega square into integration of x into dx, what? X square by 2. Therefore minus omega square x square by 2 and plus c, where c is the constant of integration, and we can find out the value of this c, that is the constant of integration. This is the equation number 1. For this find out the value of integration constant c, we can consider these particles which is at the extreme position, and when this particle is at its extreme position, then its velocity v is equal to 0, so that it can be the moves in downward direction, so that its velocity goes on decreasing, and finally at extreme position this velocity is equal to 0. But this is the maximum displacement, this is the maximum height, this maximum displacement is nothing but what? Amplitude. So that we can write, substitute here, x is equal to a and velocity v is equal to 0 in this above equation. Substituting these two values in above equation, v square upon 2, that is 0 upon 2, that is the 0. Then instead of x we can write here a, then minus omega square s square upon 2 and plus c. Okay, then this minus omega square s square by 2, take this side, then this sign should be plus. Therefore value of c is equal to plus omega square s square upon 2. Value of c is equal to plus omega square s square by 2. And substituting this value c in this above equation, okay, then we get v square upon 2 is equal to minus omega square x square by 2, and instead of c we can write omega square s square by 2. See here, v square by 2 is equal to minus omega square x square by 2, and instead of c we can write omega square s square by 2. This value omega square s square by 2 right here. Okay, then this 2 denominator on both sides, it should be cancelled. This 2 get cancelled, and remaining term is v square is equal to omega square. This should be common. Then we have to take here this plus sign s square and minus this x square. V square is equal to omega square into bracket a square minus x square. Also we can take the square root of this above equation. Then we can write v is equal to plus minus omega under root a square minus x square. This is the expression for the velocity of the particle performing SHM. When the particles perform the SHM, then its velocity v is equal to omega under root a square minus x square. V is the velocity, omega is the angular frequency, a is the amplitude, and x is the displacement. We can use this formula. It's very important in the numerical. V is equal to plus minus omega under root a square minus x square. Now the third expression, this is nothing but the expression for displacement. Then again we have to remember, if we have to find out the expression for the displacement, then we know that the velocity of particle performing SHM, which is given by, see here, this term we can write again, because to find out this displacement we remember these terms, remember this equation, v is equal to omega under root a square minus x square. Therefore we know that the velocity of the particles performing SHM, v is equal to omega under root a square minus x square. Again this velocity, instead of this v we can write the rate of change of displacement with respect to time in differentiation form, v is equal to dx upon dt. Therefore dx upon dt is equal to omega under root a square minus x square, RHS as it is. Then again rearranging the term to find out the integration of this above equation, we can rearrange the terms. Here dx, then terms of the dx under root a square minus x square and omega into dt. This terms a square minus x square under root, take this side, and dt this side. Therefore we can write here, adjusting these above terms, dx upon under root a square minus x square is equal to omega into dt. And then we can integrate above equation on both sides. Therefore take the integration sign. Integration of dx upon root of a square minus x square is equal to, omega is a constant, omega into integration of, instead of dt you have to understand better, we can write here 1 into dt, because you know that the integration form, only as there is the dt, then integration is t. If there should be the integration of t dt, then we can write the t square upon 2. Okay, therefore we can write here omega, better understand integration of 1 into dt. Then you can write this formula of this integration formula for this dx upon root of a square minus x square. In your maths you can learn this formula, integration of dx upon root of a square minus x square. This is nothing but sine inverse of x upon a. You know that this various mathematical formulae, sin c plus d, you can use in the physics, so that this integration of dx upon root a square minus x square, we can, instead of this we can use this sine inverse x upon a, and integration of 1 dt, that is the omega t, and again we can write the another constant here, and this is nothing but the alpha. Instead of alpha you can take the phi in your book. omega t plus phi or also omega t plus alpha. Then sine inverse x upon a is equal to omega t plus alpha. Again, sine inverse can take this side RHS. Then instead of this, we can write only x by a sine inverse. This is a plus, and therefore x by a is equal to sine of omega t plus alpha. Again, a take this side, x is equal to a sine of omega t plus alpha. This is the equation number 3. This is nothing but the expression for displacement of the particles performing SHM. X is equal to a sine of omega t plus alpha. This is the expression for displacement. Perform the SHM. Okay, understand you well? Next lecture we have to see here. Okay.